Now SPSS, we're back to SPSS. We're just done with those reviews. Now, so of course the process, I'll just Sharon show you what you are expected to do. Of course, you'll go to import data, and then the data was, I think, was an Excel file. So go to the Excel file, and it was the first one for my case, and then click on open, and then accept some things there. The dialog will give it some time to load the data, preview, and of course everything leave it the way it is. Just click on OK. So you get your data in SPSS. Now your data needs to be cleaned. So what I said, that for example, this column, I think what Sharon was experiencing was these columns with no internet service, no phone service. So what you were expected to do is first start with no phone service. If you start replacing, start with no phone service. Replace no phone service with say 1. And then now is when you can go and replace no. If you start replacing no, that means that every no on no phone service will change to be 1 or will change to be 0, which will give you some difficult time. So what you were to do, Sharon, if you were even supposed to load the data fresh, if you were not able to undo, because there was an undo button here where you can be able to undo your mistake. So replace, let's say if you say you replace no with, let's say, 0, then that will mean even this no phone service will be replaced, this no will be replaced with 0. You click on replace all. This is what I'm saying. So you'll see that you have 0 phone service, which is not supposed to be the case. So what you're supposed to do for you, Sharon, was just to do undo, and this will revert your data to the initial version. Then from there now is where now you can copy this no phone service. You can copy it and then now go to replace. And then now here, you now replace that no phone service. You replace it with 0, you can replace it with 1, depending, because there is no any order here. This is just nominal variable. Then it will have no issues. So you just replace all. So this will first replace anywhere there is no phone service with 0. And then now you come to replace no with, now no you can replace with 1. So this is what you are supposed to do, Sharon, for your case. And then now your things will be okay. Mine keeps on misbehaving like this, but this changes has already been infected. So this is how you are, what you are supposed to do. Now, this is Rebecca. Rebecca, can you share your final data in the WhatsApp? Share your final data set in the WhatsApp. However, I would like to, we would have been interested in exploring this data further. But for us to easily understand what we need to cover today, it has forced me to create another data set that that will make us understand the concepts we want to learn today. So I created a data set that is straightforward and it's simple. So I want us to get that data to SPSS. So I'll just do away with this data, and then new import. So let me import this data, and of course we'll share this data also with us. Yeah, just a minute, let me access my files. So I'll just pause. All of us, we want to make this data ready for all of us. So what I do, you also do, so that by the time now we finish, we all have the same data. So we do together. So I'll start fresh. So I'll go to file, I'll go to import, go to Excel. So for me now, I have this data ready. So also trace that data where you have it. So file import Excel, then locate that data that we have shared into WhatsApp. Then click on open. Click on open. Of course, you'll preview the data. Then click on OK. So this data contains, just click on OK. This data contains 1, 2, 3, 4, 5, 6. So 6 variables. That's what we call variables, which are also this side under variable view. So we have 6 variables about employee ID, department of the employee, the gender of the employee, years of experience, the performance of the employee, and then we have salary in USD. So we need to clean this data to be ready for our analysis. So label will just, of course, call this, give them names that can really reflect, make us understand these variables. So this is just department. So what I do, you also do it, you effect it also, so that by the time, because we already know, but just do what I do. Of course, we already know now the steps of cleaning this data. Years of experience, preparing the data to be ready for analysis in SPSS. And then this is performance core. Salary in USD. Okay. So I wanted us to have a data that we can easily understand. Now we have labeled our variables. That's the first thing we've done. The width of the columns, of course, we need to amend. This column is just column sizes, but this widths, this is 4. So that means these ones are 4 each. The next one is 9. Of course, these ones you can just set them, just give them 12, 12. I think 12, 12 is okay. For each 12, 12 is okay. Just to avoid, just give them 12, 12 unless there's anything sensitive. Just give them 12, 12 is okay. Yeah, so this one can remain even 4 because, of course, the employee ID is a 4-digit for now, but you can, of course, change it if you want. And then now the size of the column is where you adjust this side. You remember, here is where you adjust the sizes of the column. So you can also make all of them maybe 12, so that they can, I think this will not confuse you. Remember this, we are adjusting the sizes of the column, like the column size. How wide is the column? So you can give it like 16. Let's give it another value, because you see when we have 12, 12, someone might not know which one is which. So we just give them 16, 16, because of course there are a few variables, so we make them 16 each. All right. Once we have that in place, now the next thing is just to check that the variables, do they really reflect the true meaning of the variable? So the first is the string, the element, the employee ID string. So this is string because it contains some kind of text in the employee ID. So string is, of course, an alternative name to text. Then we go to the width. We have looked at the width. The decimals, of course, strings do not take any decimals. Label is employee ID. Values, there is no values here to choose, so there is not categorical. There is no categorical there. And of course, this is just nominal. So that is okay. Next is the department. The department is a string. In this width, of course, we agreed on that. Label is department, and then the values here for department. Department, we need to put values. Remember, these are like categories. So we need to do code book and now know how many departments do we have, so that now we can set that in the values side. So let's do code book together. How do we do code book? Can someone guide us? Just here, you tell us go here, and then do code book. Who is ready? You can raise your hand. Who is this? This is Rebecca. Okay, Rose, take us.
You go to analyze.
So we go to analyze, yes.
And then report.
We go to reports.
And then we see the.
We see code book. Just guide us the whole process. From here, we need to see, let's say we just need to see maybe the department alone.
You select department.
Select department.
And then you select the blue arrow.
You select the blue arrow.
Yeah, and then okay.
Then you click OK. Okay, wonderful. Yeah, so that is it. That's how we know like how many variables, of course, how many groups do we have in this variable. So the variable measurement is nominal. The groups that we have is finance, HR, IT, marketing, and sales. So these groups are the ones we want. And then even from here, we can know now how many finance do we have? 10. How many HRs do we have? 9. How many IT do we have? 12. How many marketing team do we have in our organization? 8. How many sales people do we have in our organization? 11. And their percentage distribution. Very key. Now we take this to our values in the variable view. So we'll start with finance. So of course we'll go to our data and then go to variables, go to department values. Of course you can note those things somewhere so that it can be easier. So 1 is finance. So finance, add 2 HR, 3 was IT, 4, let's do the same thing, marketing. So ensure you also do that at your end. Then we have 5 cells. Do we have any team left out? Yeah, sales, marketing, IT, HR. Nice. Okay, that's okay. So once you have this, ensure that you have the exact labeling as I have, because I don't want us to have different analysis. Are we together? If we are together, show a thumbs up. React with the thumbs up if we are together up to that point. Thank you, Sharon. Thank you, Rose. Now, next step is just to click on OK. And now we now have that update there. So that means now we have our HR, we have our sales, but we try to switch here, it's not switching. So that means that we need now to replace. Now we need to ask ourselves, what was the first one? Finance. So finance took 1. So copy this finance, select this column, go to edit, go to replace, then and replace, find what? Finance. Replace with what? 1. That's what you do. I'll repeat. You just copy finance, go to edit. So what we want to do is just to like replace where there is finance with 1 that we labeled the other side. So that when we switch here, 1, A and 1, we can be able to see them switching. For now, they are not switching. So we need to see that switching quickly. This one is switching. This one is switching because I edited it. So I think there's somewhere I clicked and edited it. Like when I click here now, can we be able to switch? That one is just switching. So we copy this finance. So we want that to be synchronized. So we copy that finance, select everything, go to edit, then go to replace finance, paste here finance, then replace with 1, then replace all. So that means where there is finance has been replaced with 1 now everywhere. where there was finance has been replaced with 1. Now we can be able to switch here. We can now able to switch 1 and finance. So that is not happening in marketing. We need to do that in marketing. And marketing was which number? So I'm just copying this. Marketing, we gave it which number? We have HR. Let's go in order. We have HR. Let's go in order. So HR is number 2. So we go to edit, replace HR. HR is number 2, replace with 2. Then replace all. Oh, I did not select here where we are replacing. So I select it like that, and then I'll click on replace all. So that replaces the 9 HRs that we have. Next, we ask ourselves, which one is the next one? From HR, of course, you cannot list these things down for easier readability. So I'll just change this one. I'll just change this one. I think it seems like it's been corrupted. This is HR. Yeah, has been corrupted somewhere. So I'll just change this one so that will be okay. So next is IT. So next is IT. So let me just have it this way so that I can see the remaining. So next one is IT. IT is number 3. So I'll go to edit. I'll go to replace. I'll go to replace. And then IT. Find what IT replace with 3. Then replace all. So we replace all. 11 have been replaced. So everywhere where there was IT has been replaced with 3. Now we go to the next one. Now that we know we got the next one, select marketing was 4. Marketing was 4, then sales was 5. Okay, so we go back to data view. You select the column. You go to edit. You go to replace. So you replace, find what marketing, replace with 4. Just like that. You click on replace all. It replaces everything. Where there was marketing has been replaced with 4. Next is now sales. So you'll write here sales. Replace this with 5. So we replace now everywhere was sales, replace with 5. We close. And now our data has been updated there. Any question there? Now, let's confirm that once you are done, just react with the clap. Clap. If you are done, you react with the clap so that we can know that you are done, so that we can now move to the next step. Yeah, thank you, Rose. So Sharon, just take your time, ensure you just do it correctly, because this, of course, usually alters the analysis. We don't want to reach the analysis and maybe get that maybe you have an error somewhere. So we just need to ensure that we have same analysis, doing it differently, but same results throughout. So once you are there, show some reactions. Yes.
Emmanuel,
Yes.
I had a challenge. I'll just follow you up.
Yeah, which challenge?
I was still transferring the data, so I'm a bit behind. I suggest that you just go and I'll follow you up.
Can you share your screen? We see where you are. We see if you are far or we are near. Because we want.
I'm very far. I've not even yet.
Oh, okay. All right. So let's now go on, because at least you already understand this process, right? So now, yeah. So we can now go. So next one we are going to do is gender. Are you able to work on gender as we work on it from your end?
Yes.
Oh,
Me.
okay. Let's work on the gender together then. let's work on gender together. So gender is male and female. So we go to variable view, gender is string. Then the values here will say 1 is for male and 2 is for female. And click on OK. Then now go to the data view. So we say the 1 is for male, 2 is for female. Go to the data view, select gender, go to edit. If your replace is not active, just go with find. Then under here, put male, find male, then click on replace here. Of course, you'll come now and see everything here. Of course, you can just find male, replace with 1. Just go to replace, go find male, replace with 1. Then you click on replace all. Click on OK. It has updated, so I can see it's not telling me that it has updated, but I know it has updated. So I'll just I'll just reload my data and then I'll have it. So 2 is female. 2 is female. Then replace all. So 21 has been replaced. Close. I'll just save this. My data set as employee data, employee salary data set. So I'm just saving this my data because I just need to see the reflections of the changes that I've made. So I'll just close this and of course reopen my data. I know yours is showing, but mine now I'll have to open that data for me to see those changes. Let me open and see. So I'll just switch. That's okay. Yes. So for me now everything is okay. Now we can proceed to the analysis. Any question? No question. Okay, so let's do analysis. So the first analysis we want to do, remember, we have some detailed analysis that will need to be answered from this data. However, before we go there, we just want to start with simple analysis. Like, can we say, like on average, can we say that male receive more salary than female? Or can we say male perform better than male? Female perform better than male and vice versa. So yes, yes, Rose.
Question.
Yes.
For the salary in USD part, shouldn't we change the variable type?
The salary?
For the salary in USD variable,
Yes.
should we change the type?
So because now is money, we can of course yes switch here from numeric to currency. And now because now is USD, we can just say dollars, right? And then now we can just select the first one. Dollars, not the first one, but the second one. So dollars, and then now we have it that way. Second one. You just click on OK. Yes, thank you for the reminder. Thank you for the reminder because now that is currency. Now it will come with that dollar symbol. So yeah, that is it. Now we have our salary in that order. Thank you for that reminder. Now, this is now what I'm trying to insinuate. Why do we have this data? We have this data because we want first to understand. Can we say that a particular department usually receives higher salary than the other department? Can we say that male receive higher salary than female? And can it be even job-wise? Can it be like female in marketing receive more salaries than those the male counterparts? and so on. So those are some of the questions that when you are a data analyst, you are supposed to ask yourself. No one will tell you to give insights. They will give you data the way I have given you this data, but you are the one who is supposed to come up with those kind of analysis. I have a detailed analysis that, of course, we'll try to answer a few questions from it, but you will need to spend your time working on it, answering questions from this data. So the data that we have here is from a medium-sized company that wants to understand, one, whether employee performance scores are linked to salaries. What does that mean? Employee salary scores linked to salaries. That means that as they perform, as an employee's performance goes up, does it also ensures that their salaries are also like the same, also going up? What we call a relationship. Is there a relationship between a salary and the employee performance? Like, and then the relationship, now we call it correlation. Is there a correlation between the performance of an employee and their salary? Ama wewe mwenye una perform, wewe ndio mwenye unafanya kazi mingi, you are the one who is being paid less, wewe mwenye unakuja saa mbili. Yeah, so we need to find out, is it the case? But of course, based on the data that we have here, not the other data, of course. So how years of experience and gender influence salary? Years of experience and gender. This one can be something we call linear regression. So let's try to see which technologies can we use to answer these questions. Which statistical analysis can we perform to answer these questions? Some of the questions here might require advanced approaches, but of course there is always first time for everything. And then, can we say if departments show significant difference in pay? Of course, here the different technologies will need to apply, but all can be done with SPSS because it's just navigate here and get what you want. But I will of course start with the easier ones, and then now you can build on while answering these questions with the advanced knowledge. So I'll start with simple knowledge that we need to do. First, we need to compare salaries across department. So we just generate here our simple. These other parts are really advanced. So I'll start with the simple approach is compare salaries across departments. So what does that mean? So that means that we want to know which department earns which salary on average, like the highest salary and so on. So what we do, we go to our SPSS, go to your SPSS, go to analyze, go to compare means. Analyze, compare means, go to means. Analyze, compare means, go to means. So let's say our dependent list is salary. The dependent list is salary. And then our independent list is department. So take department to the independent list and take salary to the dependent list. So what do we mean by dependent and independent? You remember we talked about input and target. That is part of data entry. Under roles, there is input and there is a target, which we call, so the target is what we call dependent in this case. So what this data can do, guys, is this data can be used to build something we call a machine learning model, something we call a model. For example, a funding model. So a funding model also works just like this one, where we have like the funds that need to be given to like the students, but we have other things that affect these funds that will tell you belong in which band. So like you have a score. So this score is what we call a target. So if some combination of your parameters, or your parents earn below 10K, or earn what per month, you maybe you live with one parent alone, or who paid for you salary, who paid for you the school fees in high school, all those things, they help to come up with a model. So as we can see this data here, this data can also help us have a model which can be able to tell, suppose we have a new employee and joins a particular department, and maybe is a female and has this years of experience, and his performance score is this, or her performance score is this, his or her salary will be this. That's what we call a model. So the data we have here can be able to build that. Before building that, we first usually use it to raise some insights from the data, because the data is as good as the model. When the model is bad, is of course as a result of data. So dependent list, or the dependent, which called the dependent variable, is a variable that can be used as a target in our analysis. It is usually called also response variable. Response variable, the one that receives the effect. So it's called the response variable. And for me, I will encourage you to also encourage you to use generative models to help you understand some new terms. This will help you a lot in understanding them, because it will break them down further, and then it will also give you other terms. For example, independent variables are also called explanatory variables, because these are variables that explain other variables, so they can explain themselves, so they are called explanatory variables. So they are independent variables. And then they are also called input variables. Input variables, why? Because they are the ones that will help you know the output, so they are called the input variables. That you'll see it under variable view, you'll see something under roles. You'll see input, target, both. So this input, so here now we have the mandate. We can now tell this guy, yo, you are the target, while these other guys are now input. This is where these things come to play. As I said, I encourage you to try using generative models. Let's say I usually have trained a lot my students with Gemini, or even other generative models like GPT. If you don't understand anything, you need to come and ask the generative model how you can do it better. So let's say this is how you can, of course, leverage on you have to move faster with technology. If you face any challenge, you need to ask the generative model first. If the generative model is not responding to what you need, then you can ask Madang. So I can be able to come in. Yeah, but at first, you need to see if you can solve it on your own. Okay, with assist of these generative models. Now, let's ask, what is the difference between dependent and independent variables in stats? So it will give you even to the examples. So it tells you in stats, independent and dependent variables are used to establish a cause and effect. Of course, it might start using the terms that are difficult. So what you do, explain to me like Standard 5 dropout. Of course, you can just say, explain to me as a layman. So this one will try to tell you, oh, you know I. So you know this. So like it will try to break it further to give you an example that you can relate. It can even tell you, oh, you know flowers. So this is how you can even use it to make you understand better. Imagine you are doing a simple experiment. You are trying to figure out something out. Let's say you want to see if giving your little brother more candy makes him run around more. Like class 5, like something you can understand. So if that is what you can understand, just tell it, Buana. I cannot understand these terminologies you're talking about. And that's how that will help you explain. But let's now not go to that side because it's more to standard 5. But let's now focus on this. Now, the key difference is that the independent variable is the cause. You see? The independent variable is the cause. That's why we are saying for an organization to know your salary, what is the cause? The cause could be maybe your gender. We don't know. The cause could be your department. We don't know. It could be your performance or your years of experience. In most cases, of course, it's around that years of experience and stuff. Now, those are what we call independent variables, like the cause. While the dependent variables are effect, like what gets the effect is what we call the dependent. I think up to that point you now understand the difference. But of course there are some more examples. Like if you're doing this, increase in this can increase new fertilizer. For example, in an experiment, to see if a new fertilizer increases plant growth, the amount of fertilizer is the independent variable. The research controls how much fertilizer each plant receives. That's now the independent. And then now we go to the dependent variables. The dependent variable is what is being tested, what is being measured. It's dependent. It depends on the changes made by the independent. And you can use your time to come here and understand, just use your generative models and see what you'll be able to make. That's how you can use it to learn. Even while I think if you watched the YouTube videos, while I was teaching also on the Google Sheets with the other student, we used a lot of Gemini because why struggle on mastering functions yet problems are different? I can teach you today VLOOKUP. You will get a problem that needs you to combine VLOOKUP, combine, substitute, combine, concatenate, everything put together. I can't like teach you like combine this function will give you this. No, I need to teach you individual functions and then tell you now you know the foundation. You will know if this is wrong or this is correct. Now you can use the generative models to help you move faster, get results. If an organization employs you today and gives you a task, you can't say this task is undone. You need to do that task. They don't want to know how. They want to see the results. So that's why in this world we are saying that AI is not going to replace you, but someone who is going to use it is going to replace you. That's what in other times it's saying. Like if you don't leverage on it, you are going to be replaced by someone else who is using it. So that's why you need to use it in terms of improving or minimizing a lot of time. You don't really need to think a lot if you can, of course, like a function that needs to perform a particular thing and you're struggling. You don't need really not to focus there a lot. You need to focus on interpretation and not on how to get the results, because interpretation also, now the human component comes in while making decision. All right. So we have seen the difference between independent and dependent. Now we can now proceed with our analysis that we were doing, we said you go to analyze, go to compare means, go to means. Take the dependent, which is salary, take it to the dependent list. Independent, take department, take it to the independent list. You can click on options, and under options here is where we usually select which analysis are we interested in. Which analysis are we interested in? Are we interested in the mean? Are we interested in the number of staffs that are in that particular department? Number of cases? Or are we interested in the standard deviation, which means the far away, how salaries are far away from the center, far away from the mean of the entire department? But of course, you can also look at the sum. Maybe you want to compare based on sum, like which departments as the on like to the total receives the highest salary, or minimum, which department receives the minimum salary, someone who receives minimum salaries from which department, and someone who receives maximum salaries from which department. So just drag, put this side. Then you click on continue. But down here, there's an advanced analysis, of course, ANOVA, table called ANOVA. So this one is an advanced analysis which will help you and even be able to make more insights. Tell you if there is a significant difference in the means of the department's salaries. And this will be able to tell you if we can, of course, say that there is that difference in terms of the mean salaries of these different departments. Then once now you have this side, you just click on OK or continue. Then you click on OK. Just click on OK here. So you'll get a table down there. You get a table starting here, means. So it's going to tell you how many cases do you have? 50 cases. Here is the report. Here is the report. So the report tells you per department. It is telling you finance has this mean of salary. HR has this mean. IT has this mean. Marketing has this mean. Sales has this mean. And the total salaries in this entire organization. Then it is also going to tell you how many members do you have in each department. So this mean is a result of 10, this other one is a result of 9, this one is a result of 12, and so on and so on. If you look at the mean, on average, the department that receives, like on average, that means that per individual in that department, per individual, like on average, an individual in that department is likely to receive 78,000 USD from marketing. If it's for finance, then an individual from finance department is likely to receive 71,506. That's on average. Same to these other departments, as you can see. But marketing departments tends to have the highest mean. Like means like most people from marketing department are getting a good money. And maybe we can look at the totals. Do we have totals? Sum per department. So which department receives the highest? Here, when you come now to sum, this other one was on average per individual. But now if we go to sum, which department receives the highest, like per department, highest salary per department? Then we can look at the sum column and see this one. IT department gets a lot of salary, highest salary, like the total salary for that department is very high. And then minimum, maybe we can look across and see which department has a minimum salary. So between this and this, these ones are, let me see, not seeing something correct here. So the minimum salary is from HR. Yes, minimum salary here is from HR. And then the maximum salary from which department? IT. Right? Yes. Ross, are we together?
Yes, we're together.
Okay, yeah. So, are you able to interpret this table?
Yes.
Okay, thank you. All right. Then now we have standard deviation. Standard deviation is telling us how far away are the people, either the ones earning higher or the ones earning lower, far from this mean per department. How are these people far from this mean per department? So what does that mean? It means that the higher the standard deviation, in one way, either to the lower, either to low or higher, or either to the minimum or to the maximum, it means that there is either someone who is earning less if these salaries are going to be, of course, the standard deviation is how far away are these values now on average. So it gets the difference to the above, below, and then now comes up with these values. So this one is telling us how far away are these guys. So it's either to the below or to the above. So plus or minus the normal measure of dispersion. That's the standard deviation. That's how compare mean is straightforward. However, this is from our own eyes. From our own eyes. We are able to see and maybe guess that, you know what? If it comes to some, then IT people are getting a lot of money. But how can we prove this? Of course, you can take this and put in your analysis now to ANOVA and measure if there is that significant difference. However, most of the statistical analysis, when the data is normally distributed, like when the data is having that normal curve of, let's say, normal curve of receiving, let's say, like the salaries, then that means we use mean. We use the mean. We use the mean is a fair representation. Mean is a fair representation when the data is normal distribution of data. But now when the data is not normally distributed, that means that if you try to plot, let's say like maybe a histogram of course in data visualization, we'll be looking at data visualization in the next session. In the last session, we'll be looking at data visualization. We'll be able to plot a histogram. Of course, you come to graphs, come to charts, builders, and then this one you just click on OK. And then now you can take your histogram to here, and then now you can put your salary to no on the x-axis. Let me just put this in the x-axis. All right, yeah, so x-axis, of course we'll learn this in the next session. And then now when the data is a lot, then you can be able to see some pattern of your data. Of course, when you click OK, then you can be able to see some options. You can also check some things here, but of course you can click OK. You can check also basic chart elements, groups, title elements, and so on. You can also check all those here. But when I click OK, I can now receive my histogram of salary. And our histogram of salary, as you can see, there's that normal curve, meaning that there is a fair like distribution. Now mean becomes a better representation of this data. You can see this is the overall view of mean. Not per department, but just the overall view of mean itself. Yeah. So you can see the mean now becomes a fair representation of that. And that makes mean a better suit when it comes to generalization. Now, suppose we are interested in answering, you see now the questions that are here are just beyond, the questions that are here are just beyond the compare means. Like this one. If departments like wants to understand if departments show significant difference in pay, this one is like you need to make a decision, not by the eyes, but also from the data. So from our simple analysis here on the departments, we have been able to see that there's some changes here, but this is not enough. You see, this is not enough. We need to try to compare, and that's what now leads people to analysis of variance, because analysis of variance will help you be able to analysis of variance will help you be able to perform that kind of analysis. So you can see like we have a lot of analysis here, and still under compare means there is this one we call one-way ANOVA, is what we are calling analysis of variance, one-way ANOVA. And now we are interested, maybe let's say, to answer that question. Like that company now wants to understand if pay differs now with evidence, not just from the figures we have seen in the means. And now that is what now will maybe make you perform that analysis further. However, for you to perform this analysis better, and if you know like you'll need to perform such kind of analysis, then you need to make your variables. You see the other variables that we have the other side, you can't see them here. Why? Because they are strings. They are strings. So for you to make those variables fair enough to be now able to perform analysis in SPSS or in data, they need to be detected as numeric variables so that now they can be used in mathematical computation. So for them to be effective, then that will mean that you need to go to your data. You need to go to your data. Go to your data. You see here, all these variables that are string cannot now be used for analysis, a serious analysis in SPSS. They will be used in codebook, yes. Might be used in visualizations, yes. But if you want to perform statistical analysis, you'll need to convert these guys to numeric. Yes, they will be numeric because you have here ones and twos. There is where now ones and twos help. There is where now ones and twos come to play. These ones and twos now help you convert this data now from string to now numeric. And then you just click OK. This one is for the department. So anything that will not be already converted in this format will be discarded. So it will be blank. So just click OK. Come to data view. No effect has happened because we already converted these things into ones and twos. If we had no ones and twos, then we would have received here blank data. What I mean is, let's do a case study of the same with this other data. So suppose I want to, let's say this one. Let's say I change this one, online security, from string to numeric without converting them ones and twos. That's what I mean. Sorry. Without converting it to ones and twos. That's what I mean. So we come here, online security is this one. Change this from string to numeric. So if you do this without having converted them into categorical, like dummy coded them, like 1 is for this, 2 is for this, then it's going to like drop that data. You can see it's going to drop that data because it doesn't now recognize that data as numeric. So it will be string, like it will be misplaced. So it will be dropped. So the best habit is to do what we did first. Just leave it as string. Then now set that variable here. Then now when you want to perform analysis on that variable, ensure you change it now to numeric. Like now for our case now, when we come to now analyze, and then we go back to compare means, we go back to one way ANOVA, then we are able to see department here. We are able to see department here. Initially, we were not able to see it here because it was still strain. So here, you need to take salary to the dependent, because remember dependent is the target, and then department, take it to factor. Take department to factor, because factor is like what is categorizing. Okay. From here, this is kind of an advanced analysis, but it's good for us to also do some things in for the first time, but of course understand why. For now, you might really not know what is it, but if you use also generative AI and ask what is ANOVA, what can be done with ANOVA, what do you need to perform ANOVA in SPSS, then you'll also get some insights. It's good to know what it can be able to do, then you can of course learn it and apply it to other scenarios like gender and so on. Now, you come to post hoc. So there's something interesting with analysis of variance, is that we just don't want to know that maybe the means are different. We just need to know which departments are having higher salary than the others. So you just come to post hoc and you'll see some heavy statistical terms here. But for this case, don't really focus a lot on these ones. But of course, you will get some other analysis specific. For example, if you're doing, let's say, freelance work, you will get some analysis requesting you to do post hoc analysis. Post hoc is called post hoc multiple comparison. What it is just basically helping you like coming up with a concrete decision. Beyond just seeing that now we can say like this department is higher than these ones. Like like there is a difference. You see, ANOVA, what it does, it just tells you that there is a difference. But without post hoc multiple comparison, you cannot be able to tell. You cannot be able to tell like which exact department is higher than the other. It's just the same way when you are doing, let's say, plant yield. Let's say you are doing agriculture and you have like demo farms. You have planted your crops in these different demo farms and you have received yields. And you really want to tell which demo farm performed better. Which one? Not that there is a difference. We need to know which one. There is where post hoc multiple comparison comes in. So when you're doing your freelance, you will receive or even doing your own analysis, you might get some people direct. They tell you in post hoc, use boniferon or use LSD. In most cases, we usually use LSD if you're not told, or use Turkey, or there's also Turkey HSD, and then there is also Turkey's B. So you'll always be told. So, but of course, and there is all these other ones, but the one that is common is LSD. If you're not told, just use LSD. So just check it. Don't even worry about who is LSD. But basically, these are inventions that were brought to help us make a decision. But of course, while interacting with it, it will make your work easier and understand the output. Just that, and then click on OK. And then click on OK. So just come to post hoc and check LSD. If you're not told, just do that. Click continue, click on OK. So like you'll get a whole analysis further. Now, as I said, this is an advanced analysis, but we wanted to test the waters and like go beyond just seeing these descriptives, and then now seeing some visualizations, and go beyond just showing visualizations to now performing an ANOVA for this fact. And know why ANOVA? Because we have more than two groups. We have finance, HR, IT, sales, marketing. If we had only two groups, then we have someone we call T-test. So we'll see that in the future sessions how to apply that. So in ANOVA, what is usually important is this F. and this sig. So F for now, you will put it on hold. Let's use sig. Sig is significance. When this value, what you need to know here, significance, this is what we call p-value. So of course, you can just ask also generative AI. If you are new to this, I'll encourage, of course, so that you can easily understand these things faster. So ask generative AI how to interpret ANOVA results in SPSS. Just that. So it will tell you that interpreting ANOVA results in SPSS involves a few steps. You need to look at a few tables in the output, primarily ANOVA table, which is this table that we have already generated, this one. And then next analysis it's recommending for you to have a look is the post hoc analysis. However, before even performing this, we usually have things like checking for assumptions of analysis of variance. So for now, we are not doing that. Let's just focus on the analysis. But of course, you can check for the assumptions later and see if our data meets to be treated for ANOVA. So let's go to the tables. So the ANOVA table is the heart of your analysis. It tells you if there is an overall significance difference among the group mean, which we have seen. F statistic is this value that I said we put it on hold because F statistic is here. This is the F statistic. But of course, when interpreting, you'll need to put it in your writing, how to write a report, analysis ANOVA report. Now, we'll proceed and check. So this is the ratio of the variance between groups and within groups, leave alone those stories, because those are just mathematicals on how to get this F statistic value. And then now the degrees of freedom, the DF, we usually call it the DF. We also need this value while interpreting, while writing the final report. And then you need the significance value. This is the sig value, which we call the p value. So this is the most critical thing that we need in our analysis to interpret. So we just need to look at that value and say, is this value below 0.05? And is this value or above 0.05? It's below 0.05, reject the analysis, the hypothesis. So there is something we call hypothesis here again that we usually set. If this again is first thing for you, just use generative AI. Ask. You see, I may mention some other terms and might be maybe new to us. Maybe hypothesis testing, setting hypothesis in one way and over. Just a simple one. Setting hypothesis in one way and over. So this is how you can use actually AI to help you like get a grasp of this. But of course, I have a recording also on this. I have trained this in the previous sessions. I have explained these things in details on one way and over. So I have these recordings already for SPSS. So I can give them access to you so that you can also go and see what we discussed during that time. So there is, of course, something we call the null hypothesis, which is usually rejected if that p-value. Just focus on maybe what I just say. So there's this ANOVA hypothesis, null hypothesis, which is usually rejected if the sig value that we have seen here is below 0.05. And what is that null hypothesis? The null hypothesis is that there is no difference between these means. Like there's no difference between the means of these departments. That's what that null hypothesis is. There's no difference between the means of these departments. So if the sig value is less than 0.05, that's a constant, 0.05 is a constant, so you need to work with it as you are. You need to work with it in your palms or in your memory. So when 0.05, when this value is less than 0.05, then that means that we reject the null hypothesis. What the null hypothesis? The null hypothesis is that these means are equal. The null hypothesis is that these means are equal. Like there's no difference between HR salary, IT salary. This is null hypothesis is just like a claim. Yeah, it's like a claim, a general claim. So a claim is that in our organization, no one like receives better salary no matter which department you're in. That's what we call null hypothesis. Now the alternative is the counterpart. The alternative is that there is a significance difference. So if this value is greater than 0.05, then we say we fail to reject. We fail to reject the null hypothesis. So we fail to reject the null hypothesis is that actually there is no significance difference in this means. So actually, what we can be able to tell from this analysis before going to know if this is relevant, just to know if this is relevant, always look at this. If this one is that we fail to reject, like there is no mean difference, there is no need for you to perform multiple comparison. There is no need for you to perform multiple comparison if there's no need for you to perform post hoc test if this value is not significant. If this value is not less than 0.05, then there's no need for you to perform multiple comparison. But if this value is less than 0.05, then this one will also be significant. Just check. So all these things are not relevant because of just this one. But of course, if you want to go further, well and good, but majority of these things will not be significant. So if all these things are not significant, then that means that there is no significant difference, except just between sales and marketing. Seems that like there's a very big difference between these two guys. However, the overall look of this means is that they're not far away from each other statistically evidence. So if this value is not less than 0.05, then you really do not need to perform post hoc, because what will you be comparing? Okay, so maybe we might just go back to our generative AI and see the conclusions down there. Alternative is there, and post hoc. Let's ask. Oh, I think there was post hoc above here. So post hoc. If the main ANOVA p-value was significant, less than 0.05, you know that there is a difference somewhere, but you don't know where that difference is. This is where post hoc test comes in. But if this value is not less than, ignore the post hoc. I think I have tried to explain that concept. Is usually difficult concept, especially for maybe someone who is not from the statistical background, because we'll be meeting maybe this for the first time. But I've tried to put it as layman as possible and also show you how you can easily understand these terminologies with the generative model that we have right now to help you understand and focus more on giving insights and making decisions quicker than focusing on the technical part of it. I don't know, Rose, if you've understood what I've explained. Yeah.
Yes.
Any question on this?
I feel like, as you said, we'll look more into using generative AI.
Yeah.
Yeah.
So of course, you just ask. You see, this some terminologies, of course, statistical terminologies. You must meet them because they are there to help you like make decisions. So we have done a very nice analysis for departments, starting from the top, where we looked at some summary statistics about the means for these different departments based on the salary. We have looked at how many people are in each department. We have looked at the sum for each department, looked at the minimum, someone who is earning the minimum salary in that department and earning salary in the maximum salary in that department, minimum, maximum, and that one now gives an overall view of the data and the department. We went further and performed a simple visualization histogram, because this variable salary is a continuous variable. That's why we performed histogram. So histogram is used for continuous data, like to represent data in a continuous manner. And you can see the data followed some kind of normal distribution. If you can see, kind of a normal distribution. And then from there, we went further and wanted to know if if the salaries differ across the departments. And now we had to perform one-way ANOVA, because we are only comparing one dependent variable with one independent variable. And then we're using one-way ANOVA instead of t-test, because ANOVA, when you look at the requirements for you to perform one-way ANOVA or ANOVA, is that you need to have more than two. You need to have two or more. You need to have two or more groups for you to compare those variables. But if you just have two, you'll have the same results as the one that you can get on t-test. We have something we call independent t-test. So yeah, these are data analysis components that we will of course use in hand more frequently. So I have a recording for this. You can of course watch that recording and use this resource to do the same for gender. So this is like an assignment for gender. Just do the same thing we have done from the top, but for gender. That's an assignment. Then save this output, share with us this output of your analysis. Share with us this output of your analysis. So that's like the assignment. So we performed one-way ANOVA. We saw this is not significant, so there's no need for you to look at this. But if this value is significant, meaning less than 0.05, then this one will be relevant. So you can be able to check and know which department is actually different from the other by looking on the significance values here. Yeah, so that is it for today's session. And yeah, I look forward to seeing what you'll be able to do with the gender. So you just come to data, perform everything we have done, but on the gender against salary. So you just want to know if male are performing better than female or female performing better than male. So we need to know the mean. You need to do the means. You need to do the histogram for salary, and then you need to do you need to do now the ANOVA for gender against salary USD. So that's just your assignment. And then, yeah, let's meet and discuss those outputs in the next session, as we'll be looking at data visualization and then the last components of analysis. And then now we'll go to Power BI from next week. Yeah, thank you so much. Unless you have a question, Rose.
Can you kindly repeat the assignment?
Okay, the assignment is to perform. The assignment is here. Compare salary across gender. So the assignment is compare. Remember, we did compare salary across departments. So compare this across gender, and then from there, help us know if gender shows significant difference in pay. Just that. If gender, not department now, but gender show, like it's the same thing we have done, but now do it for gender. Is that okay?
Okay, thank you.
Okay, welcome. Okay, thank you for joining today's session. How was it? Was it hot or was it average?
We are advancing
Yeah, yeah.
steady.
Yes, yes, yes. Like we need to be able to make decisions from data, not just like seeing data, keying in data. Yeah. We need to
Mhm.
make the data talk. Yes.
Mm.
Yeah. Thank you so much and have a nice evening.
Okay, good evening.
Okay.